Hello, my name is Brianna Burnett, and today we're going to talk about power versus work. So what is work and force? Work is the transfer of energy to an object by using a force that causes the object to move in the direction of the force. So whenever you apply a force to something and it moves, you have work. Force is a push or pull on an object to make it move. So let's look at this definition in action, okay? So we have an example. There's a girl here pushing a box. The direction of the force is to the right. The direction of motion is to the right. Is the direction of the force in the same direction as the motion? The answer is yes. She is doing work. So let's look at her carrying a backpack. The direction of the force on her backpack is up, but she is moving to the right. Because the direction of the force is not in the direction of the motion, she's not doing work on the backpack. Now, when she lifted it from the ground to her back, the backpack was moving up, the force was moving up. That was work. But just walking with a backpack on your back is not work on the backpack. In this example, she is lifting a bag of groceries from the ground. So the direction of the force on the bag is up. The direction of motion on the bag is up. Yes, it is work. As she walks forward with her bag, she is exerting an upward force on the bag, but the bag is moving to the right, so it is not an example of work. There is a way for us to calculate work mathematically. Work is equal to force times distance, or W is equal to F times D. And we measure that in joules, which is represented with a capital J. So if you look at this girl in this picture here, she is lifting weights, okay? So whenever we're looking at how much work she is doing, in this first example, she's got 80 newtons, okay? So typically we measure weight in pounds, but scientifically newtons is going to be the better option. So she is lifting an 80 Newton weight 1 meter off the ground. So if we multiply force times distance, our work is 80 joules, okay? Now let's say she adds weights, okay? She's added the red weights to this bar. So now the force that she has to exert is 160 newtons. She's still lifting at 1 meter, but the work has increased to 160 joules. Now let's say she goes higher. She took off the red weights and just has the yellow weights, okay? So she is lifting 80 newtons of force, 2 meters instead of 1 meter this time. So she is doing 160 joules of work, the same amount of work she did with the 2 different weights on the end of the bars. All right, let's look at how to solve for work. So, Robert used 10 newtons to push a box 15 meters. How much work was completed? So just like the speed problems, we want to identify first what we need. How much work, okay? So work, we don't know. We've got 2 other numbers here. We have 10 newtons, so this is our force, and we have 15 meters. This is our distance. So force is equal to 10 newtons. Distance is equal to 15 meters. So as a reminder, work is equal to force times distance. So if we multiply this out and put these numbers, plug them into where they belong, we're going to do 10 newtons times 15 meters. And if we multiply that out, 10 times 15 is 150 joules, because we're looking at work and the unit for work is joules. So here's another one. Maria knows that she completed 9 joules of work when she carried her shoes 3 meters. How much force did Maria exert? So again, I'm kind of throwing you for a loop here. We have 9 joules of work and 3 meters for our distance. It's asking us how much force did Maria exert? So before you get started, we can use the same magic triangle we used in the speed equations, but substituting in our other equation. So work is equal to force times distance. So give that one a shot. All right, so let's sift this one out, see how you did. We have 9 joules of work. So work is equal to 9 joules. Whoop, that's supposed to be a 9. 9 joules. And then we have our distance, which is 3 meters. So we're missing force. By looking at this magic triangle, if we're looking for force, we know we need to divide work divided by distance, okay? So force is equal to work divided by distance. As we plug in our numbers, we're gonna do 9 joules divided by 3 meters, and our force is equal to 3, we're looking for force, so newtons. How did you do? So now let's look at power. Power is the rate at which work is performed. And to calculate power, we use the equation power is equal to work divided by time. And we express power in watts, which is represented by a W. Now let's look at how to solve for power. So if you'll remember, power is equal to work divided by time. Okay, so again, another magic triangle here that we can put to use. Power is equal to work divided by time. So let's read through this. If it takes you 10 seconds to do 150 joules of work on a box to move it up a ramp, what is your power output? So let's identify our numbers. We're looking for power. It takes us 10 seconds, so that's time, to do 150 joules of work. So that's obviously our work. So if we plug it into our equation, power is equal to 150 joules divided by 10 seconds. We can cross out these zeros. 15 divided by 1 is 15. Do you remember the unit for power? If you said watts, you're correct. So we're going to put a W there. Now this can get confusing because in these equations I'm representing work with a W and watts with a W. So I'm not really sure how to get around that, other than what you need to realize is none of my abbreviations here are abbreviating units. They're abbreviating a piece of the equation, okay? But in the answer, you're always going to put a unit, which would be watts, or that W. So let's have you do an example here. A light bulb is on for 12 seconds, and during that time it uses 1,200 joules of electrical energy. What is the wattage, or the power, of the light bulb? Give that a shot. All right, let's see how you did. So, what is the power? So we're looking for power. A light bulb is on for 12 seconds. So we've got our time. And during that time, it uses 1,200 joules of electrical energy. So that is our work. Power is equal to work divided by time. We're going to plug our numbers into the equation. 1,200 joules divided by 12 seconds, and that will give us 100 watts. So as a quick review, work is when you are moving an object in the direction of the force. That is work, okay? The equation that we use to calculate work is equal to force times distance. Power is how fast you are performing work. And the equation for that is power is equal to work divided by time. And that is all for this lesson.